In this video, we're going to subtract two matrices. When we subtract matrices, the rules are identical to when we added them. Both matrices must have exactly the same dimensions. A row matrix and a column matrix are single-dimensional matrices, where elements are restricted to either one horizontal or one vertical line. In this example, we're subtracting one row matrix from another. A row matrix has exactly one row and can have any number of columns. The dimensions are always 1 by the number of columns. For example, a 1 by 3 matrix has exactly one row and 3 columns. A square matrix is a matrix with an equal number of rows and columns. Because its length and width are identical, it forms a square array of elements, making it the most important structural class of matrices in linear algebra. The dimension of a square matrix is often referred to as order n. For example, a 2 by 2 matrix is a square matrix of order 2. Special square matrices include the diagonal matrix, identity matrix, and this example, which is a symmetric matrix, where elements mirror across the main diagonal and where the resultant matrix is also a symmetric matrix. For any two matrices, we subtract the corresponding elements. That means, for a pair of 3 by 2 matrices, we subtract the elements in the top left corner and the elements in the top right corner. We can either include the subtraction step in our working or simply do the arithmetic in our heads. Remember that subtracting a negative number increases the number we're subtracting from, with the overall effect the same as adding. Subtraction is non-commutative, which means that their order matters. If we reverse these matrices and subtract them, every element in the resulting matrix changes sign. When we subtract large matrices, like this pair of 2 by 4 matrices, we need to be careful not to accidentally subtract an element from the wrong row or column. As long as the matrices match in size, we just subtract the corresponding positions. In our next video, we'll see what happens when we multiply matrices.